Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In our last lesson, we talked about the pressure in solid and pressure in a fluid. But today we are taking it up to the next level and we'll be looking at pressure in manometer as shown on the board. Firstly, what is a manometer? A manometer is an instrument used in measuring the pressure of a liquid or the pressure in a gas. So you can see as shown on the board, the manometer looks like a U-tube, and we have three cases or three scenarios of how we can have practical questions on manometers in our exams. So these are the three cases that you will ever come across in any question that you'll be having under manometer. So these are the three most common scenarios or cases that you'll be seeing or you'll be coming across mostly in your exams. So let's look at all these cases one by one. Now, for the first case, you can see we have the gas column and you can see we have the height of the gas pressure. You can see the height of the gas pressure is H2, and on this column we have the other height, and the other height can be mercury or water. So those are the two most common liquid used in a manometer. So for this case, you can see we have the height, which is the H1, and on the other hand, we have the gas height, which is the H2. And looking at the second column, you can see it is closed on top of this column. So this is a closed end. So for this case, the pressure of gas, which is P gas, will be equal to the pressure of the height. So the pressure of the gas will be equal to the pressure of the height because this is a closed end. There's no atmospheric pressure coming into this manometer, and that is why we have the pressure of the gas to be equal to the pressure of the height of the column. And this height, the height can be given as H equals to H1 minus H2. So the first height here, which is H1, minus the second height, which is H2, will be given by the total height. So we have that the P gas will be equal to the pressure of the height. So for any manometer, the longer side or the longer column, we always take the first height, which is H1, and the shorter one, which is the shorter column, we always take the second height, which is H2. And that is all about the first case. And the second scenario or the second case, you can see we have the gas height to be greater than the height of the other column. So the gas height being greater than the other column, we take the H1, and the second column, which is the shorter column, we take the H2. So in this case, you can see this is opened. So you have your atmospheric pressure here. So you have your P ATM in this case. So because this is an open end, there will be an atmospheric pressure flowing into the manometer. So for this case, since the height of the column or the height of the gas column is greater than the height of the liquid column, we have our P gas to be equal to the atmospheric pressure first, which is P ATM, minus the pressure of the height. So we have our pH. So in this case, because the gas column, the height of the gas column is longer than the height of the liquid column, we are going to subtract the pressure of the height from the atmospheric pressure, which is the pressure that is flowing into the manometer. So for this case, remember that the height will be given as the H1 minus H2. So in this case, the pressure of gas will be equal to the pressure of the atmospheric pressure flowing into the manometer minus the pressure of the height that we have in this column. So you can see we have the minus. Take note of this sign because this sign is essential when you are doing your calculation. So now, because the gas column is greater than the height of the liquid column, you can see that we have the pressure of the gas to be equal to the pressure of the atmospheric pressure minus the pressure of the height. And this is all about the second case. And to the last case, observe a difference between this case 1 and case 3. You can see in this case, this is a closed column, but this case, this is an open column. But they have the same height on the liquid column and the same height on the same liquid column. So in this case, this will be our atmospheric pressure, which will be P ATM. And for this case, since the height of the liquid column is greater than the height of the gas column, we will have our P gas, which is the pressure of the gas, to be equal to the P ATM plus the pressure of the height. And this case, observe the difference between this third case and this second case. You can see in this second case, the pressure of the gas column is greater than the pressure of the liquid column. So the pressure of the gas column is longer than the pressure of the liquid column. So we have our pressure of gas to be equal to the P ATM, which is the pressure of the atmospheric pressure, minus the pressure of the height. And the last case, which is the third case, you can see we have our liquid column to be longer than the gas column. So the pressure of the gas will be equal to the pressure of the atmospheric pressure flowing into the manometer plus the pressure of the height, because this case the liquid column is longer than the gas column, and that is why we are using the plus in this case. So you can see the first case, there is no atmospheric pressure, which is the PATM, because this end is closed. So the pressure of the gas will just be equal to the pressure of the height. And this case, you can see the liquid column is taking the longer height. So the H1 will be on the liquid column. And the second column, which is the gas column, you can see it is taking a shorter length. So the H2 will be on the shorter length. So to get the height, the H will be equal to the H1 minus H2 for this case. And for this second case, you can see there is an open end, so the atmospheric pressure is flowing into the manometer. So the pressure of the gas, which is the P gas, will be equal to the pressure of the ATM minus the pressure of the height, because the height of the gas column is longer than the height of the liquid column, and that is why we are using minus in this case. And for the last case, which is the third case, you can see the liquid column is longer than the gas column. So the pressure of the gas will be equal to the pressure of the ATM plus the pressure of the height. And this is the formula that we will use for any question under manometer, because any question under manometer will not exceed either of these three cases. Now, let's look at practical examples under manometer. But before we look at practical examples, remember under the standard atmospheric pressure, which is the STP, we have the pressure to be equal to 760 millimeter mercury or 76 centimeter mercury. So either of these two is correct depending on the parameter you are trying to work with. So you can use the 760 millimeter mercury or the 76 centimeter mercury. So this is important to note because there are some questions that they won't give you the standard atmospheric pressure, that you have to know it yourself to be able to solve the question. So now let's look at examples under the pressure in manometer. So the first example we have, as projected on the screen, says that when one arm of a U2 manometer is connected to a gas supply, the level of mercury in the two arms of the U-tube are as shown in the diagram above. If the atmospheric pressure is 76 centimeter mercury, the gas pressure is... So in this case, you can see we are given the atmospheric pressure, which is the 76 centimeter mercury. And looking at the diagram, we have the height of the gas column to be 3.5 centimeter. So in this case, looking at this diagram, what cases do you think will be applied to this diagram as shown on the screen? So if you observe this question very well, you can see the height of the liquid column is longer than the height of the gas column. So the height of the gas column in this question is 3.5 centimeter. So the height of the gas column, which is the pH, is equal to 3.5 centimeter. And secondly, we are given the atmospheric pressure, which is the PATM, to be equal to the 76 centimeter mercury. So in this case, you can see we are having centimeter and centimeter, so we don't need any conversion in this kind of question. So the question now, looking at this formula, they are asking for the pressure of the gas. So the question is asking us, what is the gas pressure? So the formula for this case, looking at the diagram in this question, you can see the height of the liquid column is longer than the height of the gas column. So we'll be applying this formula to this kind of question. So the formula says P gas is equal to the pressure of the ATM, the atmospheric pressure, PATM, plus the pressure of the height. So in this case, what is our pressure of the atmospheric pressure? So we have the P gas to be equal to 76 plus 3.5, which is the pressure of the height. So in this case, our final answer, which is the P gas, will be equal to 79.5 centimeter mercury. And this is our final answer to questions of this type. So you can see the diagram in the question. You can see we have the longer height, which is on the liquid column, and we have the shorter height, which is on the gas column. So we'll be applying this case theory to this kind of question because the liquid height is longer than the gas height. And this is how we solve questions of this type. And to the last examples under the pressure in manometer, we have that in the diagram above, if the atmospheric pressure is 760 millimeter, the pressure in the chamber G is given as what? And in this case, looking at this diagram, you can see that the height of the liquid column is greater than the height of the gas column. So we are still going to be applying this third case formula to this kind of question. So we have the height of the liquid column to be 10 centimeter and the height of the gas column to be 3 centimeter. So we are going to have H1 minus H2 to get our final height. So let's write our given parameters. So we are given the pressure of the atmosphere, which is the PATM, to be equal to 760 millimeter mercury. And we are given our height, which is the height of the liquid column, which will be H1, to be equal to 10 centimeter. And we are given our H2, which is the height of the gas column, to be equal to 3 centimeter. So in this case, you can see we are having this in centimeter and this in millimeter. So we have to convert this kind of question. So let's get our final height first. So the H will be equal to H1 minus H2. And our height will be given by H equals to 10 centimeter minus 3 centimeter. So in this case, our height will be given as 7 centimeter. So now we have to convert this 7 centimeter to millimeter. So how do we convert this 7 centimeter to millimeter? Remember from your arithmetic, we have that 10 millimeter make 1 centimeter and 10 centimeter make 1 decimeter. And we have that 10 decimeter make 1 meter. So we have that 1000 meter make 1 kilometer. So if you are trying to convert from 10 millimeter to 10 centimeter, so if you are going down, you will divide. And if you are going up, you will multiply. So what does this mean? This means that if you are trying to convert 10 centimeter to millimeter, which means if you are trying to convert this 10 centimeter to 10 millimeter, so the gap between this bridge is 10. Now that we want to convert 10 centimeter to 10 millimeter, we have to multiply whatever we are converting from centimeter to millimeter by 10. So in this case, we are converting 7 centimeter to millimeter. So we are going back up. And when we are going back up, we multiply. So when we want to convert 7 centimeter to millimeter, we have to multiply it by 10. So to convert this, we have that our final height will be equal to 7 multiplied by 10, which will be equal to 70 millimeter. And this way, we are successfully convert our 7 centimeter to millimeter. Now, back to our formula for pressure of gas. So we have that our P gas will be equal to the atmospheric pressure, which is the PATM, plus the P height. And we are using plus because the height of the liquid column is longer than the height of the gas column. So you'll be using this formula. But assuming the height of the gas column is longer than the height of the liquid column, we'll be using subtraction in this case. But we are still having questions of this type. So now that we know that our PATM is equal to 760 millimeter mercury, so we can say our 760 millimeter mercury plus our final height, which is the pressure of the height, which is 70. So in this case, if we add this together, we will get our P gas to be equal to 830 millimeter mercury. And this is our final answer for questions of this type. And that is all about pressure in fluid and pressure in a manometer. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And in our next video, we'll be moving to another topic. And until then, don't forget to give this video a thumbs up. And don't forget to hit subscribe to Tech and EduSpark Hub so you won't miss any tech content or educational school lesson coming up your way. And until next time, keep learning, keep coding, and I will see you in the next one.